Hello, everyone. Let's see. Today we talk about the PCX file format. Picture exchange, the ZSoft picture exchange file format, primarily used in PC Paintbrush. Yeah. So you probably wonder why I'm talking about that format. And this is a format that is unlike the others that we covered so far. So far, we covered GIF and PNG. And this format was completely close to the hardware, so really with the different hardware in mind. And that's had impact on its evolution. And to say the least, its evolution was not the smartest, which led to a few problems. So basically it's an interesting format that has some historical significance close to PC hardware, but also the way that evolved and it was created really highlighted a few design mistakes that's just that shouldn't be that should possibly be avoided if you if you design a file format. And so let's say I have this very small, not this one, sorry, EGA 16. Yes, so this one, but of course there is some gradient happening. So let's take another viewer, EGA 16. Yes, this thing. This is the pure EGA palette. And EGA is the ancestor of, is one of the first. So basically CGA had 4 colors. So CGA is something like this. Maybe this rings a bell. 16 4 colors, beautiful pink and yeah, well, that was how it was. EGA was 16 colors. The same, I mean same as in you couldn't choose the palette, so it was hard to to produce nice looking graphics with it. So congratulations to Mark Ferrari. And then came incredible thing that was the VGA, and the VGA enabled people to just have not a lot of crazy colors, but 256 colors, but out of way more. See what I mean? So, but it was certainly new, and the fact that each color, it was all indexed. So basically, you had a palette of 256, and basically each pixel was a single index in the palette, which enabled palette effects very easily. I mean, it was a part of the hardware. So now let's look at the EGA image, and I already have already a VGA one. Even though they look quite similar, we'll see that both store the information the way the hardware was doing at the time. PCX was created for PC Paintbrush in '84, at the time where the EGA card, video card, was already existing. So the 16 color was already a thing. I created earlier some CGA pictures with a very early paintbrush version. Yeah, well, anyway, we'll see that it was not as uh, covering every aspect of the CGA and EGA basically. Anyway, the file format starts with something already very not controversial, but it starts with it has theoretically no magic. It starts with a byte set to 10. That's the ZSoft value. In the specification, it's always 10 indeed. And so basically it should be a value, but it's always fixed. So this is a big rule in file formats. Don't what is variable should be variable. And if it stays the same, then nowadays basically every PCX starts with A, which is not the way it was thought. I don't even know why it's 0A, while there was only one manufacturer as far as I know. And there's no magic, so making disk detection a bit harder. Yeah, already some formats had magic back then. um, it's already a good weird decision. Then another thing that is shocking is that the version is a second byte, set to 5, and And the specifications say that for version 2.5 of PC Paintbrush, it should be 0 and so on. And earlier, I booted this beautiful thing that is that is PC Paintbrush 1.2 from 86, and I created a CGA file out of it, just the pattern. This thing, I mean, it's displayed incorrectly in this case. It should look more like, oh, actually, let's load it. Let's load it. Let's show you to show you the beauty. Oh, okay, I deleted the file because, of course, I did. Oh, come on. That's a mistake. Anyway, I can show you with this. It looks a bit more like this. It's just patterns, you know. And it should be pink and blue, but just this image, you know. And this image created with 1.2 with version 1.2 in CGA. Well, it has a version of 5, so it looks like the specification itself is just wrong. Like it's totally not version 3.0, and it's not. You see what I mean? I'm running a super old version, so the version number seems wrong already. Okay, and then there is early encoding, which itself doesn't look like it. I mean, here this byte is set to 1. So basically it means there should be run length encoding, and if you see my pattern, oh, it's not. Oh no, it is full of repetition, and yet there is no encoding. So it looks like the header, the specification and header totally disagree already. Okay, I won't dig too much into this weirdness already, but then you have just the X and Y and the DPIs. Okay, and now something that is weird is that just after this, at offset 10, you have a palette, if there is any. So in the case of the EGA palette, in the EGA file, it just used the standard palette. So basically, this area is. Oh, that's not the same file. That's weird. Okay, that's not the same file that I'm looking at here. Okay, it's another one that doesn't have palettes. Okay, and maybe I erased the palette. Anyway, so the palette should be here. Okay, then the headers continues for some reason. So the palette was from 10 to 3F, from 10 to 3F. Then the header continues, even though usually it's a one-liner. I like that the one at 40, the one at 40, here it says reserved, should be set to 0, is supposedly storing the graphical mode. You know that the one that you set with the interruption 13 video call. Wait a minute, is it interruption 13 or is my memory failing me? It is interruption 10, so of course, and mode 13. Okay, so basically this value should be the mode that you use to initialize the graphical mode, you know. But so this is what is said, but I couldn't find any such a file, and even the ones created with tools or the one created with Paintbrush itself. So at 40 should be the video graphical mode. Well, it doesn't really matter. And then at 80, at A0, there is the actual image data. And what is interesting is that the image data is stored exactly like it is in the real hardware, which is in the case of EGA, it's the bit planes. So you have the bit planes per byte together for each plane, and the plane order is blue, green, red, intensity. So intensity to choose whether you have a dark or light version of the color. So basically, the data in the case of EGA PCX is directly what you would put in memory to display the actual image. So really something that is absolutely not RGB. I mean, it's really exactly what you would copy in the file. In the hardware. So basically PCX is made so that it's as close as possible from the hardware. It's there was no other standard doing that, but it gives you the interest. It's really matching the hardware. And this is exactly what we're going to do with the VGA image. And in this case, a very similar thing. So very similar thing, except that VGA, as I mentioned before, is indexed palette, and And now there's a problem that the palette is 256 colors. So that's like 256 inside 3. And that doesn't fit in the previous space that was just between 10 and 4 and 40. And what did they do? Then they came up with a hack, even though there was some space for the data. Well, this space is now empty. So if we look at the file, we see that the whole space for palette is empty. Then there is the second line of the header, because of course, because again, this hasn't changed. And this is empty because it's actually never used. It's reserved, this whole area 50 to 70 f set f. And then comes the pixel data. And in this case, again, because it's VGA, it's index palette, so basically every byte, it's 1 byte per pixel. And then there is this weird marker that says, hey, here is, just to make sure, I don't know why it's 12. This is the palette marker. And then comes the palette. So this time RGB, and I think the palette should be complete. And now this is another problem, that how is the palette found? Is it following the data, or is it at the beginning, at the end of the file? So is it like you go back to the end of the file and then you go back up 768 bytes before, and you see if there's a marker, then it should be the palette, and not? Or is it like you just follow the data, and then you, after all the pixel data, you multiply the height and width, and then you get where the palette should be? And of course, this is what I did. I created a file that is both, that has one palette just right after and another palette right after it. So in this case, you see that I just played the trick that all my pixels are just actually it's a 16 by 16 image that just use every possible color. And then you just have to insert one palette for one image and another palette for another image. You see what I mean? And of course, what you could expect is happening. On some viewers, it displays this. I mean, it's a trivial example, right? And with another one, it just displays this. But you could basically have any image 16 by 6. You could have a mix of two images of 16 colors, and then you play with the palette to swap the pixels. You see what I mean? So as you can imagine, as you can see, as you can see, the design of this format was really a bit clunky. Like, hey, let's do a version number, manufacturer value, but never change it. And then, oh well, let's put the stuff, the palette here. And even though the weirdness behind all this is that there is a version number, but we saw that it's used in a weird way. But there is a version number, so they could have said, hey, version 6 of this format now has this properly organized, and it doesn't make sense. It's very clunky. That suddenly it's like this. There again, this is a VGA. So this is the first part of the header. This is unused palette space, because why not? And then, oh yeah, this is the second part of the header. The thing is, for TGA images, Targa Vision image, you had a specific video controller or something, a huge component that enabled to display this image in high color on hardware. So basically, in this case, the format was bound to a specific hardware, but it's not the case for Paintbrush, as far as I can tell. So I don't see a reason why things are so hard coded, why they couldn't set an offset, why they couldn't, I don't know, define a new version, why even the version which is always 5, even though with very old PC Paintbrush version. Oh, by the way, that's the Paintbrush that eventually was bought by Microsoft and became Windows Paintbrush, by the way. So another thing that was interesting would be that yeah, of course, there's no room for metadata at all. So it's not even a very good file format for that. So no possibility to put comments or whatever. So it's not the greatest file format. not the most forward thinking. And then there is, of course, when we saw that a com file could be more or less anything. I mean, like as long as the first bytes are executable. And then it sounded like this format would be awesome to just add a small com stub. So of course, because this format is very bound to the hardware, very close to the hardware, it totally makes sense to make a standalone viewer out of an image. And this is exactly what PCX to com is about. Yeah, but then someone would be doing polyglots out of it. Yes, yes, exactly. And this is what I so that's a suggestion from Pierre. Indeed, that's what I meant. Like it really feels that this hardware could be with because there is the COM format on the same OS. Then it's the perfect place to do a P6 that is also executable and displays itself. And when I knew about P6 to come, so turning your standalone P6 file to executable files that render the same way, then it kind of makes sense. But no, because if you look, sadly, it doesn't start with a very good code. If you have a header, it doesn't start with very meaningful instructions. So I think they should have left the two first bytes empty so that you could add a jump or something. So it's a very it P6 and com felt like the a polyglot that would totally make sense because yeah, for example, PDF and com is okay, is totally okay as a polyglot. We saw that with Poker GTFO2 being a master boot record and a PDF polyglot. But no, for they missed the opportunity for making a there's no possibility of com and P6 polyglot. And what I like is that it's a com file. So from the first bytes, it starts with set EAX and then turn on the graphic mode and then load the data. Like it's direct to the point. It's still a very small payload compared to the original file, but it really feels like a missed opportunity here. Okay, so what else do I have? What did we go through? So a format that's bound to hardware where stuff that you change doesn't change, where versions have a weird reason to be. I mean, why version 5 when you use a very old version? Yeah, old hardware, and again, no room for metadata, no room for evolution, and so on, and ambiguity of palette location. So yeah, so I think that's all I have for you today. But it's just that you saw a few things not to do regarding file format design. I think this is a lesson to take away from P6, the P6 file format. And yeah, I mean, it was definitely the easiest format to dump a screen to, or to the easiest standard file format to dump a screen to, or to display, to render images yourself, which is probably why got a lot of traction. It was really an interesting format as long as DOS was a thing. And then when you didn't have the way to directly set the graphical mode, then yeah, this format is now looks clunky and a bit and quite obsolete. And unlike other formats like the printfox on C64 or many other formats for some hardware, the PC hardware still evolves. So basically, you could upgrade your graphical rendering, and therefore the same system more or less could suddenly have a very different way of storing information. So thank you for your attention, everyone. And yeah, see you next. If there are no more questions, then I'll see you. I'll say see you next stream. And thanks again. Bye bye.